Hello, everyone, and welcome back. We're on 715 related rates for one more time, and this time we've done Pythagorean's theorem, we've done related rates, and now we're going to look at trig applications of it. Okay, so here's an example. I'm watching a hot air balloon take off. I'm standing 100 feet away, and the balloon is increasing 5 feet per second and is currently 500 feet of ground. If my eyes are 6 feet above the ground, at what rate is my viewing angle changing at this exact moment? So as I'm watching the balloon get higher, how is the angle changing that I'm watching them at, So let's draw a picture of this idea. So you have a balloon that's taking off. This is a bad picture. Let me make it a little bit more accurate. So you have a balloon taking off. I am 100 feet away, so here I am. Here's the ground. My eyes that I'm looking up at that balloon are 6 feet above the ground. Okay. And the balloon is currently 500 feet above the ground, and it's increasing by a rate of 5 feet per second. So if I call this h, you'll know that dh dt is equal to 5 feet per second. Okay. And I want to know, how is my viewing angle changing? How much more do I have to look up and up and up as the balloon is increasing? So how can we relate everything here? Now, if I call h this entire side, which I know we have it as 500, but what that would mean is in this triangle, we would know that this is going to be h minus 6. Okay. So then what we could say here is that we have the tangent of the angle is going to equal opposite over adjacent. And then we can differentiate how this is changing with respect to time. So the derivative of tangent squared is by chain rule derivative of the outside, leaving the inside alone, times the derivative of theta with respect to time, which will give us the derivative of the angle with respect to time is equal to, now remember, 1 over 100 is a constant, so I might pull that out in front. And then what's the derivative of h minus 6? Well, that's going to be dh dt, and then plus 0, because the derivative of 6 is 0, so I don't need that. Good. So then what I get there is if I divide secant squared to both sides. Now, if I divide by secant squared, just a little trick, is then I'm going to have a 1 over secant squared. And remember that 1 over secant squared is cosine squared. So I actually can just write this as cosine squared of the theta over 100 timesing by dh dt. Okay. So that's great. Now, how does this help us solve this problem? So we want to know, how is my angle changing at this exact moment? So that's when the height is 500 feet above the ground. Okay. Well, if the height is 500, then if we look at this triangle over here, break this triangle down. Here's 100. And if the height is 500, that means that the height of this triangle is going to be 494, because the 6 feet will make up from the ground to my eyes, which tells you about Pythagorean's theorem is this is 100 squared plus 494 squared. Okay, I'm not going to necessarily simplify that. So what we have here is that the cosine of my angle would then be, it's going to be cosine squared of my angle. Oh, wait, why am I writing that? Cosine is adjacent over hypotenuse, so that's 100 over 100 squared plus 494 squared. And all of that's being squared because it's cosine squared over 100 times, and then dh dt is 5 feet per second. That's the rate at which the balloon is increasing, so timesing by 5. If I put all that in my calculator carefully, what I'll get is going to be well, let me rewrite this a little bit first. Let's write this as 100 squared over 100 squared plus 494 squared. And then I'm going to write this as timesing by 5 over 100 over here, just to make it a little bit easier to put in a calculator. So we have 100 squared divided by 100 squared plus 494 squared. And then all of that is going to be timesing by 5 over 100. And what I'll get is that my viewing angle is changing by 0.00, we'll do a few numbers out, 197. And what we're talking about is radians per second. radians per second. And in a way that makes sense. So basically what that's saying is it's hardly changing. And you think about it, well, if a balloon is 500 feet off the ground and increasing by 5 feet per second, well, 5 feet relative to 500 isn't that much. So if I'm already looking up 5 feet, I might not even notice it. My angle might just increase by just a little bit. So that does make some sense there. But that is the idea of looking at related rates with now trig functions, and you can see how that comes into play. Okay. Hope that helps. If you have any questions, feel free to reach out or come to office hours. All right, bye-bye.